Now, our fact for today is that acceleration of objects due to gravity, that force that pulls us onto the Earth, it's around 9.8 meters per second squared. So if we were to ignore air resistance, or what we call drag, then the speed of any object falling to the Earth will increase by around 9.8 meters per second for every second it falls. So the longer an object is falling, the faster it will be traveling. Now, this is true until an object reaches terminal velocity, where those forces of gravity are being balanced by the air pushing up on the object. You'll learn more about that at the end of the notes when you watch the video on skydiving. Now, we're talking about these balanced and unbalanced forces. So if you force the object, it will move. If you force it, if you apply an unbalanced force, it will force it to move. By the end of this lesson, you need to be able to explain the difference between a balanced and an unbalanced force, including some characteristics of each. And you need to be able to determine the net force acting on an object. So as we talked about before, a force is a push or pull that is put onto an object. Those forces have magnitude, meaning they have a size. That would be the number answer you get. And they have a direction, which would be represented by an arrow pointing in the direction the object will move. We measure forces in a measurement called newtons. The shorthand for newtons is a capital N, and forces usually occur in pairs. An easy one to think of would be something sitting on a desk. You've got gravity pulling it down, you've got the desk pushing up on it. It is just sitting there, meaning those forces are balanced. So a lot of forces, most forces are going to be occurring in pairs. So when you are lifting something, when you're dragging something, those are examples of forces as well. Now, we talked about balanced forces in the simulation video. Equal forces acting on an object in opposite directions are considered balanced if they are equal and going in opposite directions. Balanced forces will not change the object's motion. Whatever the object was doing, it will continue doing if those forces are balanced. This gets at Newton's first law of motion, sometimes called the law of inertia. Objects in motion stay in motion. Objects at rest stay at rest unless acted on by an unbalanced force. So if the object is stationary, it's not moving, it will continue to not move if those forces are balanced. We also saw in the simulation that if the object is already moving and you apply a balanced force to it, it will continue moving at a constant speed in whatever direction it was already going. That again is that law of inertia. The net force, we can calculate net force by combining all of the forces acting on the object. We talked in the simulation about how if they're going the same direction, you add them. If they're going opposite directions, you subtract them. For balanced forces, that net force is always going to be 0. In a tug-of-war game, this would be a situation where the teams are equally balanced. They have equal force applied to the rope, and no team will win. Some examples. The book you have sitting on a table. An airplane. The pull of gravity is counteracted by the lift of the plane. A boat sitting on the water, the upthrust of the water is equal to the weight of the boat pushing down. Or if you have two people pushing with the same force or pulling with the same force on an object. Please interpret this force diagram. We have 7 newtons pulling to the left. We have 7 newtons pulling to the right. You could also have 2 people pushing on the box, 7 to the left and 7 to the right. Again, those arrows are both going opposite directions in both pictures. So here we would subtract those numbers. So 7 minus 7, and your net force would be 0. The box would not move in any direction, so we would not have that force arrow drawn. Unbalanced forces are when they are unequal and they are going in opposite directions. This changes the object's motion. It can speed it up, it can slow it down, it can cause the object to change direction or change shape. the net force for an unbalanced force is going to be anything other than zero. So in the case of tug of war, this is when we would have one of the teams being stronger than the other and they would win. Examples: cars driving down the road. The force of them going forward is stronger than the force of the road and the friction pulling back on it, resisting that forward motion. If we have two people that are unequally balanced, we're going to have two forces that are not the same. The stronger force will be the direction the object will move. Occasionally, we have two people going in the same direction, as in the example with the box and the two people on the same side. So in a force diagram, if they're going opposite directions, again, we subtract. So we would have 7 newtons minus the 4 newtons, and we wind up with 3 newtons to the right in the left picture. And then in the right picture, we wind up with 3 newtons to the left. So in this example, we've got the answer for the force diagram. You need the amount of newtons you have as your resulting force, and then the direction of the object moving. So you need to draw an arrow when you're doing force diagrams. So let's think of a problem here. A man has a mass of 75 kilograms, and he has a weight of 750 newtons. Now that 750 newtons is going to act downward on a table, and the table will exert 750 newtons back up on the man. So what's going to happen when he sits on the table? Talk to your partner about this. Well, when he sits down, nothing exciting will happen. The table will support his weight. Now, what if that same person happens to sit down on a table that provides less than 750 newtons of upward force? Well, hopefully you realize that less than 750 is not equal to 750, which means there will be a change in the motion. So instead of sitting on that table and not moving, that table will break and the person will fall to the floor. So here we have a girl going down a slide. We're going to assume it's a windless day. We need to come up with at least 2 forces that are affecting the motion of the child as she's going down the slide. Well, everybody on planet Earth has probably had experience with gravity. Gravity pulls things to the ground. So gravity is going to be pulling her down the slide, but she doesn't fall straight down to the ground. There is something there that is resisting that straight down movement. In this case, it's the slide. It is counteracting some of that gravitational pull so that she doesn't fall straight down to the ground. So gravity is pulling down, the slide is pushing up. We also have another force that is resisting her forward motion, and that is because she is in contact with the surface of that slide, and we call that force friction. Friction resists the forward motion of an object. So again, gravity is pulling her down the slide is pushing up on her, and friction is resisting her forward motion.